Dynamic programming or DP algorithms are recursive algorithms which store information about prior recursive calls of a given routine in a table to avoid redundant subproblem calculations. To see what I mean, let's look at a simple example using the Fibonacci numbers. The nth Fibonacci number fn is given by the recursive relation fn equals fn minus 1 plus fn minus 2, where f0 equals 0 and f1 equals 1. A naive implementation of an algorithm to calculate fn would be to recursively calculate fn minus 1 and fn minus 2. This is, however, a very inefficient implementation as the number of recursive calls scales exponentially with respect to n. We can observe that one of the reasons why this algorithm is so slow is that we are making several redundant calculations throughout this process. If we could store these fi values the first time we compute them rather than computing them from scratch every single time, we can effectively truncate this tree, significantly decreasing the runtime of the computation. Consider instead an algorithm where we store prior computed values of the Fibonacci sequence. In particular, initialize an array of size n plus 1 and store f0 equals 0 and f1 equals 1 at indices 0 and 1 respectively. To calculate fn, we will simply calculate f2, f3, and so on until we reach fn. Since each iteration of this calculation simply involves summing two precomputed values that are already present in the table, each iteration has constant time complexity. Since we have to compute n plus 1 values of the Fibonacci sequence for any n greater than 2, we therefore have that the complexity is O of n, or linear time, a significant improvement from before. This approach, which fills the DP table starting with the simplest case and works its way up to the problem of interest, is known as the bottom-up approach. An alternative method of using DP involves starting instead from the problem of interest and recursively splitting the problem into simpler subproblems, storing solutions to intermediate subproblems that are solved along the way. This is known as the top-down or memoization approach. In general, dynamic programming can be applied when a problem fulfills two main requirements. Firstly, it has an optimal substructure, meaning that we can obtain the optimal value of a problem by somehow combining the optimal solutions to its subproblems. And secondly, there are overlapping subproblems, meaning that a naive algorithm would run through the same subproblems repeatedly and perform redundant calculations. Check down below in the comments or in the description for the full video.